Why is it that some structures in our world are strong and stable, but others aren't? Today, we're going to look at the different structures that allow them to perform a certain task.
There are two factors when it comes to determining a structure's strength. One is the use of materials. The other is the way the structure is built. From the Three Little Pigs, we know that wood makes a better house than straw, and bricks make an even better house than wood. But why is that? It is because of the way atoms in the material are put together. Atoms are small little molecules that make up everything. You can imagine them to be little circles. Depending on how tightly or how loosely the atoms are packed together determines whether the material is strong or not. A good way to improve the strength of a structure is to switch from a weak material to a strong material, much like Little Piggy did. But remember, that's not the only factor that makes any structure strong. There's also the way you build it. Why is a bridge less likely to fall over than a street lamp or a pole? The answer is because of the way it's created. Bridges consist of many crosses and triangles, while poles are just a straight line going up. Triangulation and crossing membranes are two ways that make structures strong. This is just a fancy way of saying that adding triangular shapes to a structure makes it strong. Why do we do this? Well, that's because a triangle is the strongest shape of all shapes. It always keeps its shape no matter how much you move or bend it. This is because of the angles in the triangle. The angles in a triangle are fixed. A triangle has 3 sides and 3 angles, and each angle is fixed by the side opposite to it. Crosses are also made of triangles, and that's why we use triangles to enhance a shape's strength. Try this, for example. Stand up with your legs placed together and have a friend try and push you over. It's pretty easy to tip, isn't it? Now, spread your legs farther apart so that this time your legs form a triangle as you stand. Now have that friend try and push you over again. Not so easy this time, is it?
It is time for gravity and stability. These two things are related with each other. The gravity of an object affects its stability. Take a car, for example. First, we have a thin car and a fat car. Since the gravity of the thinner car is higher than the gravity of the fatter car, the thinner car is less stable than the other. In other words, the higher the gravity, it is more easy for the car to fall. Why does a thinner car have a higher gravity? This is because of the area of the bottom of the car. Since the thinner car has a smaller area for the bottom, the less stable the object will become. This concept can also be seen on yourself within your own body. Isn't it always harder to stand and not fall with one leg than 2 legs on the ground? This is because the area of the base is smaller when you have one leg, and when you have a smaller area of the base, you are not that stable anymore.
Every structure has a different use. That is why each structure has a different strength and stability, as you have seen at the beginning of the video. An example that could represent both of these is a chair. In terms of strength, a chair needs to be made of the right materials and built in the right way. Obviously, a chair cannot be made of weak materials such as straw or paper, otherwise it wouldn't be able to support you. The chairs you are sitting on right now are very likely to be made of sturdy materials such as plastic or metal. Now check under those chairs. Is there a metal X supporting your chair? This is an example of crossing which increases the strength of a structure. If there is not, then your chairs have not reached their highest strength potential. Now think about the stability of your chair. Count how many legs it has. Certainly it has at least 4. The reason for this is to increase the stability of your chair. If it only had one leg, sitting without falling would be a harder task than doing your homework. By increasing the number of legs or area touching the floor, we are spreading out the total pressure from you sitting on the chair. Imagine each leg is a person. More people makes it easier to carry something heavy, right?